So somebody give me a function. Doesn't have to be real simple. Give me something that's medium in complexity. We'll call it f of x. Be creative and don't be quiet. Give me a function. Somebody. Help. Matt? Square root of x plus 5. Good. Somebody else give me a different function. Let's call it g of x.
Fifth root of x minus 7.
Oh man, fifth root. Fifth root of x minus 7. Okay, this is getting complicated. What if I said do the following? This is going to be pretty messy because of these examples. What if I said I wanted you to take, and see if you can understand what this means. We know that if I put something in this parentheses right here, that is going to become what? Up here. Whatever I put here becomes the input. Remember we started this course out 5 weeks ago that way. Okay, this is our input. So whatever's in here is the input to this function f. Here's the recipe over here. So what we're going to do, whatever we put in here is going to get put right there, right? So if I gave you something like we've seen before, like a, then the result here would be square root of a plus 5. Right? Everybody's feeling really good on that. Okay. Here's what I want to do, though. I want to take that function Todd came up with, and I want to use it as the input to the f function. So all I do is I come up and look at the outside function here, which is this square root, and then I have to take the input and stuff it in right there and then add 5 to it. So that means I have to come in here and put my fifth root of x plus 7 as my input inside that square root function. Now you won't see this problem in the textbook because it's so messy. But do you have the idea? We just composed or made what we call a composite function, where one function acts as the input to another. Oh, I'm sorry. How come it's plus 7? Did anybody else catch that? Nobody else caught it? I'm glad you were awake back there. Okay. The original function that Todd came up with was the fifth root of x minus 7, and so that input should be fifth root of x minus 7 right there. Thank you. Okay. Let's grab a couple out of the book. We're over in chapter 5 right now. And if I go to a problem set and look at, say, something like number 18, if f of x is absolute value of x minus 2, matter of fact, nice little quick review. Over on the side right there, draw a little quick sketch of that. And then while we're at it, the other function they give us is 3 divided by x squared plus 2. And with a little bit of thought, you should be able to sketch that one as well. This should not take any brain power at all at this point. It's an absolute value function, V-shaped. What happened to it? What happened? To the right 2. Good. So we have a function sitting over here. And you label to 0. Look at this one down here, g of x, for a second. G of x has a horizontal asymptote because the numerator is lesser degree than the denominator. Here's a rational function, folks. As a matter of fact, you could use the reciprocal thought. and just put a 3 multiplier on it. You could think of a sketch of x squared plus 2. Watch this. Let's see if you internalized what I talked about real fast a few minutes ago. If you draw a sketch of x squared plus 2, you know that's a parabola sitting up here like this, right? Now, imagine you're going to draw its reciprocal. Positives stay positive. Minimum becomes a maximum. X squared plus 2, the y-intercept here is 2. What's the reciprocal of 2? 1/2, right? This goes towards infinity, right? Heading up towards infinity. And so that's blowing up. This has to be blowing down, doesn't it? Oh, here's another interesting thing. Even functions stay even. If you replace x with minus x, isn't this still the same? And this is the reciprocal of that type of a deal. So this even function has to stay even in its reciprocal. To make a long story short, a minimum becomes a maximum. Got the picture? Looks like that, doesn't it? There it is. A little squashed looking thing. There's the picture of it. Okay, that isn't what we're up to here. That was just a quick review. What I want to do is what they ask us to do in that problem in the book. Anybody have the book open? They probably say form f of g of x or form g of f of x. Anybody see it? What the instructions were? Oh, it said do some different things. Yep. Here's what the textbooks asked on that one. And I never write it this way. The only place you see this usually from people is in a book. This does not mean fog, okay? What this means is what I talked about a moment ago. Take the g function and use it as the input to the f function. Okay? So that's what we want to do. F of g of x is going to be, we're dealing with an absolute value function, and we're going to lay this reciprocal function, this rational function, in there as the input up here in the absolute value function. This isn't too tough, is it? Composition stuff. Let's reverse it. Let's take g of f of x. You folks go ahead and write down what you should get. So we have the g function, which is 3 divided by its input being squared. So we take the absolute value of x minus 2, and we have to square that quantity, and then add 2 to it. Is that okay with everyone? Okay. What can you tell me about, now would we leave it this way, is my thought. Would we leave it this way? To answer the question that was asked in the book, if it said find g of f of x, we could leave it this way, but could we simplify this? What do you know about this thing in parentheses when you square it? For sure, it's going to be positive. So do we have to really worry about those absolutes inside that square? I don't think so, right? So why don't we make life a little simpler in what we write down? We could go ahead and write that as 3 over that x minus 2 being squared, and then add 2 to that denominator. And then we could expand that. And we reviewed expanding binomials, which brings me back to something I'd forgotten to mention in this course earlier. I'll give it to you here in a second. expanding of its binomial square, you square the first, you take the product of the terms and double them, and you square the last, and then don't forget to add that 2 on the tail end. And so we end up with a final result here, 3 over x squared minus 4x plus 6. Which is a rational function. So the composition, in this particular case, the composition g of f of x yields this particular rational function. Let me glance in the book and see if there's anything else in this section that needs to be mentioned here in class. Oh, and before I do that, let me not forget the basic algebra item I wanted to review. Any questions so far with this? Anybody going to have trouble here? Not too bad, as long as you know how to put one function inside another. Okay. You have learned since beginning algebra how to factor a difference of squares, and we reviewed this earlier in the course. And you have to know that like knowing your name. Right? Have to know that. Here's one that people have trouble remembering. I don't think I'd mentioned this earlier in the course. A difference of cubes. Have I mentioned this before? I don't think so. Also, we have a sum of cubes. And people have a hard time remembering how these things factor. Here's the world's best way to remember it. If you can identify something cubed plus or minus something else cubed, if you can identify the problem as being that way, then it's easy to get started. This is going to have a factor of a minus b. This one down here is going to have a factor of a plus b. Now, the hard part for people to remember from your intermediate algebra is what goes over there. How many of you know? 2 of you, 3 of you, 4 of you. Okay, let's see if you're right. All you do is, when you look at this, this is easy to get started. You square the first item, put it here, in either case. You take the product of the terms here, minus AB, and change the sign of it, and put it there. Same thing down here. Product is AB, change the sign of it, becomes minus AB. And then square the last. Squaring the negative makes it positive. Down here, squaring the B makes it still positive. It's that easy. So if you see a sum or difference of cubes, let's say I did something like 64x to the 12th minus 27. See it mentally as 4x to the 4th being cubed minus 3 cubed. Becomes 4x to the 4th minus 3 times the mess following the pattern. Square the first, 16x to the what? Be careful. Squaring this is x to the 8th. Take the product as negative 12x to the 4th, change the sign of it, plus 12x to the 4th, and then square the last, plus 9. Done. 99% of the time, the quadratic expression here will not factor. Will not factor, so you don't have to even put any brain power on it. Okay, I wanted to make sure I got that in there because these sums and differences of cubes do show up. I think I saw it in some of your homework recently. Okay. All right. Let's take a look in the book and see if there's anything on composite functions that needs to be covered. Oh, what if you put the same function back into itself? What that's called is called iteration. It's where you take a result, you take a process, and you take that result and feed it back in on itself. It's kind of like having say a grinder. and you grind up the, say, apples, and then you run them back through, you take that apple, ground up apple stuff and run it back through the grinder a second time, or a third time, okay? So if you take the same function and stick it back into itself. So let's see if we could find one to do that with. Let's try number 44, just to play with this a little bit more. Number 44, let's come over here. Two x minus 1 over x minus 2. G of x is x plus 4 over 2x minus 5. Anybody see what I did with the cap of the pen marker? Oh, here it is. Got it. Thanks. Okay, let's do the following. I don't think I need to do f of g of x or g of f of x. There is something that would be useful in doing that. I think I'll hold off though. Let's do it. It's good fraction practice, and you need practice with fractions. So let's do f of g of x. It's going to get messy, but in math, all you have to do is write it down neatly and carefully take step-by-step processes with it. So it looks like we're taking this fraction here, g of x, and we're going to stick it in the numerator and denominator. So we're going to create what's called a complex fraction, because it's going to have fractions inside a giant fraction. So here's what we're going to get. We're going to get 2 times x plus 4 over x minus, or 2x plus 4 over 2x minus 5 times the 2. Take 1 away from that. And then down underneath that mess, we're going to take this g of x function and subtract 2 from it. Okay. You've seen this stuff before back in intermediate algebra. This is called a complex fraction. There is a fraction here. You could think of the subtracting 1 as a fraction, and you could see down below here, you could think of this subtracting 2 as a fraction as well, right? So we have, think of these as all fractions. Now, the world's best way to clean these things up is to take the entire numerator and the entire denominator and multiply each by the common denominator of all the fractions you see. This one's is easy as far as the denominator goes. The common denominator happens to be a 2x minus 5 is needed. 2x minus 5. So if we take 2x minus 5 here and multiply the denominator by it as well, then all we're really doing, and think of these as over 1, so all we're really doing, this stuff we're multiplying by over here is really just a value of 1. So it's still going to remain the same as the original problem, except it's going to be cleaned up, even though it doesn't look like it. Now watch what happens in one step by doing this technique of multiplying by the LCD top and bottom. You distribute the 2x minus 5 as a multiplier on here, and you lose the 2x minus 5s, don't you? Okay, so what we get, and I only have about a minute left, what we get in the numerator for f of g of x is just 2 times x plus 4 minus, don't forget now you have to distribute this times the 1 too, so minus the 2x minus 5 divided by 2x minus 5 times this first fraction. You lose the 2x minus 5s and you get an x plus 4 minus 2 times, don't forget to distribute the 2x minus 5 again right here. And look what happens in one step. This will always occur. You will always lose the fraction, the complexity, and it turns it into a single fraction. Now look what happens here. Do you see a positive 2x here and a negative 2x there? Those cancel out. In your numerator, you're left with a plus 8 minus 5 becomes a plus 5. And down below, we end up with how many x? You should be doing this as quickly as I can. Negative 4x here, plus x. Negative 4x plus x is negative 3x. And then finally, 4 plus 10 is 14. This cleans up a little bit. So f of g of x, final result, happens to be 13 over negative 3x plus 4. You always want to clean these things up. So there we've had now a couple examples today of how to compose one function, or essentially stuff one function inside another function. Any questions? Tyler?
Negative 3x plus 14.
Oh, plus 14. Oh, made another typo. Thank you. You guys are awake today. Good. Okay. Negative 3x plus 14 right there. Thank you for catching that. And on that note, we'll let you go. And don't forget, there's a homework quiz that's due by the homework quiz, the 5-point little homework quiz. That's due by tomorrow, I think. But check your email that I sent you. And also, there's a 20-point quiz that I think is due by Wednesday night. Okay.